Question number 29, SAT test number 2. That's the calculator section. You have a system of equations y equals 3 and y equals ax squared plus b. And the question is, for which of the following values of a and b does the system of equations have exactly two real solutions? So this is what you're being asked here. I noticed that y equals 3, so I can use that fact and substitute it in the second equation. So now I end up with 3 equals ax squared plus b, which is a quadratic equation, so I'm going to subtract 3 from both sides, and I'll end up with 0 equals ax squared plus b minus 3. And I do need that quadratic equation to have exactly two real solutions. We do know that the discriminant of a quadratic controls the number of solutions that quadratic has. So the discriminant of any quadratic is b squared minus 4ac. And in order for this to that particular quadratic to have two real solutions, the discriminant has to be greater than 0. So in our case, b squared minus 4ac has to be greater than 0. B squared, we don't have a b in our quadratic, it's going to be 0. So 0 squared minus 4, a is a. In my case, c is going to be b minus 3. That has to be a positive number. When I simplify that expression, I end up with negative 4ab plus 12a has to be a number positive, a positive number greater than 0. Now, all I'm going to do, I will check which options, A, B, C, or D, satisfy that requirement. So for the first option, I will have, and I will clear up some area here. For the first option, I will have, and I'm going to change the color since negative 4 times negative 2 times 2 plus 12 times negative 2. If I'm plugging in the values of a and b, that's clearly not a positive number. That actually is 16 minus 24. It's going to be a negative 8. So a is not an option. For b, when I start plugging in, I'm going to have negative 4 times negative 2 times 4 plus 12 times negative 2. This here is going to be a positive number. Actually, I'll have 32 minus 24, positive 8. So b is a positive number, and I'm going to select this as my answer. I am not going to check C and D because I know I have only one correct answer, but if you do make the substitutions there for the corresponding values in C and D, you will find out that all of them produce a negative expression, so there are not going to be a solution. However, the most important thing here to remember is that when you have a quadratic equation, the number of solutions is controlled by the value of the discriminant. In order to have exactly two real solutions, that discriminant has to be a positive number. If the discriminant is exactly 0, you have one real solution, and if the discriminant is a negative number, then we do not have real solutions.